Example 4.4.3. The setup for this one says you are offered the following investment. In exchange for a single cash outflow of $25,770.97 today, you'll receive 3 payments at the end of the next 3 years. If the investment offers an 8% annual rate of return, what payment is it offering? All right. We again have a time value of money problem. We've got cash flows happening at different points in time that we're asked to evaluate. So we're going to use our 3-step process, where step 1 is to map out the cash flows. Step 2 is to use that map of the cash flows, that timeline of the cash flows, to identify the type of cash flow we're looking at. And then once we've identified the type, then we can move on to step 3, where we select the appropriate tool with which to evaluate those cash flows. So let's start with our timeline. At time period 0, or today, we're going to have a cash outflow where we're going to purchase this investment, and we're going to pay $25,770.97. And then once we purchase the investment, we're going to receive some cash flow at the end of the next 3 years. See if we can even that up a little bit. All right, and we expect to earn 8% on this investment. All right, so that's all the information we have in the problem. The question is, if we pay $25,000 today and we want to earn an 8% rate of return, what payments over the next 3 years would we need to receive in order to pay us that 8% annual rate of return? All right, so let's see what we're doing here. In fact, let's go ahead. I'm going to replace these question marks with PMT, or payment, since that is what we're looking for. All right, so we have a single cash outflow up front, followed by 3 cash inflows. It's going to be the same cash inflow over and over again for the next 3 years. So now we need to figure out what type of cash flow we are looking at. Is it a lump sum? Is an annuity, or is it a perpetuity? Well, we know it's not a perpetuity because the cash flows stop at the end of year 3. So it's either going to be a lump sum or an annuity. And of course, the lump sum formulas and calculator solutions will always work for any type of cash flow. But if we can identify this as one of the annuity types, either an ordinary annuity or an annuity due, then we have a shortcut. We have a shorter formula that we can use, or we could use the time value money keys to evaluate the problem all at once, rather than having to deal with each cash flow independently. So if we look at our cheat sheet with the different types of cash flows and timeline examples, we have, in fact, under the ordinary annuity, we have something that looks awfully similar, where we have some cash outflow that's unidentified here, the present value of the cash flow, followed by 3 level payments, that is the same payment over and over again, at the end of the next 3 years. Now, an annuity does not require 3 years worth of payments. It just so happens that we selected these example timelines from the text, and so they match the ones that are in the text. It could be 2 years, it could be 5 years, it could be 360 months over the course of a mortgage. The number of payments does not dictate whether it's an annuity or not. Just the fact that we have level payments at regular intervals that stop at some point, if we have that, then we're dealing with some type of either an ordinary annuity or an annuity due. And since the payments in this particular problem are happening at the end of each period, right? We make the cash outflow today, and then at the end of this year, we receive the first payment, and then all 3 payments are received at the end of those years. Well, then we're dealing with an ordinary annuity. The other option with level payments is an annuity due, and with that, we would have the cash flows happening up front at the beginning of each year, and that's not what we have here. So we know we're dealing with an ordinary annuity. All right, so we have an ordinary annuity. And once we know that we're dealing with an ordinary annuity, then we know what tools are available to us to evaluate the problem. We could use either the present value or future value of an ordinary annuity formula, just depending on what we have, what information we have, and what we're trying to solve for. We could use the time value money keys on the calculator, and as always, we could use a spreadsheet. And this video, like the others, is going to focus on the formula and financial calculator solution because that's what will be available most likely during an exam. Okay, so for the formulas, we'll start with the formula and then we'll look at the calculator solution. We have two formulas from which to choose. We have the present value of an ordinary annuity and we have the future value of an ordinary annuity. So let's look at the problem and see if we can figure out if one of those is going to make our lives easier or not. Okay, so we're solving for the payment. We know we're not looking for either present value or future value, but if we're solving for payment, then we must be given either present value or future value. And in this case, we have the present value of this annuity. We know the single cash flow up front that is going to buy us those three cash inflows. So I want to use the present value of an ordinary annuity formula because I'm given that piece of information. You could use the future value of an annuity formula as well. In order to do that, though, you would need to convert this present value to a future value and then plug it into the formula, so it would be an extra step. We're just making our lives a little bit easier by selecting the present value of an annuity formula. All right, so the present value of an annuity formula, ordinary annuity formula, is equation 4.05. We've got the payment divided by the interest rate times the quantity, 1 minus 1 over 1 plus r to the n. All right, so the present value as of, let's make our timing concrete here, present value as of time period 0 is equal to the payment 1 year later, so payment sub 1, divided by the interest rate times the quantity, 1 minus 1 over 1 plus the interest rate raised to the n, where n is the number of payments or the number of compounding periods in the annuity. All right, let's plug in the information that we've got. We know the present value is $25,770.97. The payment is what we're solving for. We're going to divide that by the interest rate of 8%, expressed as a decimal, that is 0.08. And then we're going to multiply that by 1 minus 1 over 1 plus r. R again is 0.08, so 1 plus 0.08 is 1.08, raised to the 3. And there we go. We've got everything plugged in. We have one equation and one unknown. So what we need to do is solve for the payment. We've got to get this payment variable by itself on one side of the equation or the other. So we've got to do a little bit of algebra to get this solved. I'm going to start by dividing both sides by the quantity in brackets here so that it'll cancel out on the right-hand side and load to the left-hand side. So let's divide this by 1 minus 1.08 cubed. And I've got to do the same thing to the other side. Okay, and when we do that, it's going to cancel out on the right-hand side since anything divided by itself is 1. And on the left-hand side, we are left with 25,770.97 divided by that big old quantity of 1 minus 1 over 1.08 cubed. And all that is equal to the payment divided by 0.08. All right, I've almost got payment by itself here. What I need to do to get it by itself is multiply both sides by 0.08. When I do that, they'll cancel out on the right and it'll be by itself over there on the left, so that on the left-hand side, we have 25,770.97 all of that we had before times 0.08 is equal to the payment of this annuity. All right, let's plug that into the calculator and see what we get. I'm going to work this in chunks. I'm going to start by working what's in the brackets here and store that value. So 1 minus 1 divided by 1.08 raised to the 3 equals, and I'm going to store that on the 1 key. And I'm going to write a little note to myself to say that I stored that value on the 1 key. All right, so now I want to divide the $25,770.97 by that 0.2062 that I just calculated. Now what I don't want to do is clear this value out and then retype in the 4 decimal approximation, because I'll introduce a pretty substantial rounding error. Instead, what I'm going to do is type in $25,770.97 divided by recall 1. So here it looks like it's recalled the same 4 decimal approximation, but in fact it's recalling the full 13 decimal version, and I've just set the calculator to only show me 4 decimal places, but it is still using the full version. All right, so it's going to do that division with the full value, and we can multiply that times 0.08, and we get a payment of $10,000. Okay, so we came up with a value, which is great. Let's go back and talk about what that value actually is and make sure it makes sense, that we came up with a number that at least passes what I call the smell test, right? It smells right. It seems like it's about right. All right, so if we go back and look at our timeline, if we pay $25,770.97 today and then receive 3 cash inflows of $10,000 at the end of the next 3 years, right? That's a total of $30,000 that we're going to receive. But remember, we're going to earn an 8% rate of return, so what we pay to receive those cash flows should be something less than the sum of those cash flows, right? If we paid exactly $30,000 in order to receive those cash flows, then it would be a 0% rate of return. They would be exactly equal. So it does make sense that those payments sum to something that's a little bit more than the cash outflow that I'm expecting. That does seem about right. And of course we know, because we've worked with these same cash flows in example 4.4.1 and 2, that $10,000 is the number that equates these things. That is the present value of that annuity at an 8% discount rate. So it looks like we're good to go there. All right, let's also look at this. That's, if you're like me, that type of algebra is not a lot of fun, and it is extremely easy to make mistakes while you're working through that, either in order of operations or typing something in the calculator wrong or making a misstep in the algebra itself. So when I'm dealing with annuities like this, once it gets past 2 or 3 payments, I'm usually reaching for the time value money keys on a calculator, just because I can solve it all in one step, and it tends to reduce the opportunity for making errors. So let's also look at the time value of money keys for solving this particular problem. Okay, and we have, I'm going to write them in the same order they appear on the calculator, just in a vertical orientation, only because that's the habit I got into. I encourage you to come up with your own system for making sure you work these problems the same way every time. N is the number of payments, or number of compounding periods in the problem. For this one, that's 3, because we're going to have 3 payments at the end of the next 3 years. I over Y is our interest rate. That is 8% in this problem, and remember, it is expecting a percentage, so we put in 8 instead of 0.08. Present value is what cash flow happens at the beginning of the timeline. And in this example, we're going to have a cash outflow of $25,770.97. And adopting the perspective of my pocket as the investor, that is going to be a cash outflow. So I'm going to record it as a negative. Payment is what we are solving for, so put a question mark there. And then future value, I'm actually going to enter a 0. And that's not because the future value of this annuity is 0. I am asking the calculator to solve for payment. So it's going to apply the time value money relationship to the present value and future value that I put in order to come up with the payment. So since I am solving for payment, the other cash flow keys, the two other cash flow keys of present value and future value, need to be not the present value and future value of this annuity, but instead what cash flows actually happen on the timeline. And on this particular timeline, we have a cash outflow of the $25,000 at time period 0. We have 3 payments of something. We're going to solve for that in a second. We know, of course, it's going to be $10,000. But if we just jumped right into the time value money keys, we wouldn't know that. We have 3 level payments. And the only time I would put a value on the future value key when I'm working a problem like this is if there was another payment in addition to this last payment. Because once I've set n equal to 3 and I'm solving for payment, the calculator knows that there are 3 payments of whatever value it's about to solve for. What goes on the future value key would be anything extra that happens in addition to that last payment. Well, in this problem, that's nothing. There's just the last payment, so we can go ahead and leave that, or we'll go ahead and enter that as a 0. All right, let's plug these guys in. I'm going to start, as always, by hitting second clear TVM to 0 out all the values on the time value money keys. And then we can enter these guys. N is 3, so we'll press 3, and then press N to store it. And we can see our sideways triangle, our decimal places, and the equal signs. We know it's stored. I over Y is 8, so I'll press 8, and then I over Y. Present value is a minus $25,770.97. Hit plus minus to make it negative, and then press PV to store it. Payment is what I'm solving for, so I'll skip over that for the moment. Future value is 0, which it should have recorded as 0 when we cleared out the time value money keys, but just to be sure, I'm going to press 0 in future value so that I know for sure that it's got a 0 on it. All right, we've got 4 of the values recorded. We can solve for the 5th by hitting Compute PMT, Compute Payment, and we see our asterisk there that tells us it is a calculated value, and it came up with the same $10,000 value that we got using the formulas. All right, and as always with these, I'm working it with both the formulas and the calculator, and in some cases using both the time value money keys and the cash flow worksheet with the calculator. You, of course, do not have to do that while you are working these problems. I'm just doing both so that we can see both solutions. Some students are going to want to use the formulas, some are going to want to use the calculator, and working through the formulas also helps build an intuition for what's going on inside the calculator, which in my experience makes it a lot faster to master the time value money keys when you have an idea of what math is going on in the background, and you also develop a sense for what an answer should look like. Just like we were talking about with this solution on the payment, we were expecting the payments to be something that would sum to something a little bit more than what we're being asked to pay so that we would earn a positive rate of return. Right? That's kind of easy to see as you're working through the math and a little bit tougher to see if you're just plugging values right into the time value money keys on the calculator.